Hello everyone, let's look at some numericals based on electric potential. Example 1 says 2 point charges less than microcoulomb are placed 10 centimeter apart. Find the potential at the midpoint of the line joining them. So there are 2 point charges of same value. So the charges are plus 10 microcoulomb, and one more charge here is plus 10 microcoulomb. There is separation between them. This distance between them is given as 10 centimeter. Question says find the potential at the midpoint of line joining them. Suppose the charges are kept at point A and then point B. Then the distance between A and B is 10 centimeter. The midpoint between them would be some point, let us call it as C, such that distance between point A and C would be 5 centimeter, which is half of 10 centimeter, and here it is again 5 centimeter. We have learnt in theory class that each of these charges will create their own potential. Let that be called as VA and then VB. VA and VB are the electric potentials because of charges kept at point A and point B. Therefore, the total potential would be scalar addition or just normal addition of the two electric potentials. Also recall that electric potential is given as the charge by 4 pi epsilon naught into their separation. So in this case, I put it back here, it is equal to, and the value of 1 by 4 pi epsilon naught, which is called as k, that is equal to 9 into 10 power 9. That is equal to 9 into 10 power 9 into charge here is 10 into 10 power minus 6 by 5 into 10 power minus 2. And observe that even this potential because of B is same as that of A. So you can write this as twice because the potential of A and B are same. So from here 5 ones are 5 twos are, and this would give us 10 power minus 4, 10 power plus 9 minus plus 10 power plus 5. Therefore what we get from here is that is equal to 2 into 2 is 4 and 4 into 9 is 36. 36 into 10 power plus 5, that is 3.6 into 10 power plus 5 volt. So this is the potential at this point C. Example 2 says calculate the potential of the electric field produced by the nucleus in the first orbit of hydrogen atom, given that the radius of the first orbit of hydrogen atom is 0.53 angstrom. So if you take the center of the atom to be the nucleus, for hydrogen atom the nucleus contains one proton. So charge of proton is same as charge of the electron, which is 1.6 into 10 power minus 19 coulomb. The distance between the nucleus, the first orbit, so this distance here is given as 0.53 angstrom. So this is given as 0.53 angstroms. 1 angstrom is equal to 10 power minus 10 meter. The radius of the atom is measured in terms of angstrom only. So remember this connection. We need to find the potential at this point. So as seen in the previous numerical, the potential is given as K 2 by R, that is equal to 9 into 10 power 9 into Q would be the charge of the proton, because the nucleus has only one proton. That will be 1.6 into 10 power minus 19 coulomb by R, which is 0.53 into 10 power minus 10. So from here it becomes 10 power minus 9. So this and this gets cancelled. So the powers goes away, and what remains would be 9 into 1.6, which is 14.4 by 0.53 is equal to 27.17 volt. So this is the required answer. Example 3 says point charges plus 5 microcoulomb and minus 6 microcoulomb are placed at 2 points. Find the electric potential at a point distance of 3 centimeter from each charge. So if we take the two charges as plus 5 microcoulomb, the charge here is minus 6 microcoulomb, and let them have some separation. The question says find the electric potential at a point which is a distance of 3 centimeter from each charge. So that point at which we need to find the electric potential cannot be to the right of this charge, because at any point here the distance would be unequal. Similarly, that point cannot be to the left of this charge, because anywhere here it will be again unequal distance. The only possibility is that this point is somewhere along this line. So if we take that point to be somewhere here, and the distance between this and this now remains same. It's the meaning of it. So let's call this as some point P. The distance between this charge, let the charge be kept at point A, and this is point B. So it would be same, which is 3 centimeter, and this also is 3 centimeter. Again here, the electric potential at this point P would be sum of the potential because of both the charges, is equal to, we do directly here, so 9 into 10 power 9 into, this would be 5 into 10 power minus 6 by 3 into 10 power minus 2 plus of 9 into 10 power minus plus 9 into minus 6. Keep in mind that when it comes to electric potential, we put it with polarity also. So into 10 power minus 6 by distance is 3 into 10 power minus 2. Look at the powers first. This would be 10 power minus 4. There is 10 power plus 9 minus 4, so it becomes 10 power plus 5. So the powers are 10 power plus 5, and 3 ones are 3 threes are, so it becomes 3 into 5, that is 15. This is equal to 15 into 10 power plus 5. Minus comes out from here, minus of, again same thing here, 3 ones are 3 threes are, so 3 into 6 is 18, so minus 18 into 10 power plus 5, that is equal to minus 3 into 10 power 5 volt. The net potential here is negative because the distance of the point from these charges are equal, but this charge minus has a higher magnitude, hence this would dominate. That's the reason that the potential here is negative. Example 4 says charges plus q, minus q and minus 2q are placed at the vertices of an equilateral triangle. What is the potential at the circumcenter of the triangle? And here we need to express the answer in terms of capital R, where capital R is the radius of the circumcircle. To understand this, let's draw the triangle with the vertices as A, B and then C, and this is an equilateral triangle. Now if we draw a circle with the given radius, then this charges would fall on the circle, and let this be the center circle called as O. Distance from here is R. Now for this triangle, this O itself becomes its circumcenter. A circumcenter is a point where three lines will intersect. That is, from point A, if we draw perpendicular onto the other line BC, this would be a line. Similarly, from this, say, point B, if we draw a bisector onto the line AC, it would go like this. Similarly, from this point C, we drop a bisector or the perpendicular onto this line AB, it goes like this. So this point where three lines intersect is called a circumcenter. In this case, that becomes the circle radius. So to keep it simpler, we just draw the radius. But keep in mind the distance of O to B or from O to A, or this also would be same. That is same as the circle radius only. The charges are plus Q, minus Q, and minus 2Q. Again here, the potential would be the sum of the electric potential because of charge kept at point A and then point B and point C. It is equal to K Q by capital R. This is minus K 2Q by capital R. This is minus K Q by capital R, because here the charge is minus Q. This and this gets cancelled. Finally, what remains is V is equal to minus 2 KQ by capital R, but the answer is in terms of epsilon naught. So minus 2 Q by R, and this K is equal to 1 by 4 pi epsilon naught. So from here 2 gets cancelled. Finally, what we get is electric potential is equal to minus Q by 2 pi epsilon naught into R. So this is the required potential. The answer is negative. That is because the effect of these two would cancel each other. This is what is creating the field.